Hi, this is Gilles, the radio prepper. You know, I'm a big fan of hand-fed antennas because they are so practical and easy to set up. We have two kinds of hand-fed antennas. We have the half-wave hand-fed wire and the random wire, which isn't really random, and I'll explain. The most practical and I would say ideal length for an antenna is a half wave. So for example, on the 20 meter band, which is 14 megahertz, we would use a 10 meter wire, about 33 feet. You can easily calculate the length of that wire by using the 468 divided by the frequency in megahertz. Or, if you're metric, 143 divided by the frequency in megahertz, and that gives you a half wave length. Now that sounds pretty simple, but where do you connect your coax cable? Well, the most common way is to make a dipole. So you take your 10 meter wire from our example, you cut it in half, so you have 5 meters plus 5 meters. And we are going to feed it right in the middle. So you take your coax cable and you have the center connector, you have the braid, which is the shielding around. So you connect one of the wires to the center and the other wire to the shield. And that makes a dipole. We have to consider something called impedance. And impedance is basically just resistance to the passage of current for AC current. Imagine you have a black box, you don't know what's in it, and you would like to make a current pass through it. So you take your two wires, connect it to your box, and again, you don't know what's inside, but you're going to put AC current, alternate current. So the polarity goes back and forth so many times per second, and of course, if we take our example of 14 megahertz, it would do that 14 million times per second. That's pretty fast. Now, what you want to measure is the resistance that the box is giving you to the passage of the current. And that's called the impedance. If we were using DC current, it would just be called a resistance. But since it's AC, and of course radio frequency current is AC, alternative, well, that's called impedance. And if we take our dipole, our two 5 meter wires for the 20 meter band, and we feed it to the middle, the impedance is 71 ohms, which is the unit of measurement for impedance and resistance. Now, if you take your 10 meter wire and you feed it at the end, meaning that you take your coax cable and you only connect the center wire to your 10 meter wire, well, you still have a half wave antenna, but it's fed to the end. What happens in that case is that the impedance is very high. It's not 71 ohm anymore, it's 4,500, 5,000 ohms. And of course your radio wants to see 50 ohms, so the radio wants 50 and your antenna is giving you 5,000. What are you going to do? Well, you need a transformer. You've seen me use a small device called a 9-to-1 unun, which is an impedance transformer. It divides the impedance by 9. So it is meant though for a random, not really, length of wire. By random I mean that anything that's not a half wave, because a half wave is going to give you a very high impedance. Of course, it's the ideal length, but it's great to make single band antennas because those are the most efficient. But if you want a multi-band antenna, you better use a random wire. So you have less impedance. You take a 9-to-1 unun, which is going to divide that impedance by 9. So let's say you have a few hundred ohms. You divide that by 9 and you will be closer to 50 ohms. And then you take care of the remaining difference with a tuner. Now, if you want to make a single band antenna, you better use a half wave wire. And if you want to feed it at one end, you have to use a 49-to-1 transformer. And that's what we're going to do today. I hope I'm not confusing you. I'll recap to make sure it's clear. If you want multi-band operations, you're going to use a random wire, which isn't really random because, of course, we want to avoid half-wave lengths for the amateur bands. So there are a number of lengths that are well known and good for the amateur bands, and I will put them right below here. What you need for your random wire is a 9-to-1 Unun. And I suggest you go check the EARCHI, EARCHI page. It's the Hawaii Emergency Radio Club. They have a PDF document that describes the building of that device, and it's very clear and very easy to do. So that's what you use with a random wire. What we are making today is a half-wave antenna. So we'll use a 49-to-1 transformer. And for that you need a toroid core and a capacitor. The toroid cores are made of different mixes of materials. The one we're going to use is 43 material. I think I'm going to try also with 31 and 61, 31 for lower frequencies and 61 for higher frequencies, but I was told that it wasn't going to work, but maybe it's worth a try. But we're going to use 43 material. Toroid cores are referred to by their size and the material. I'm going to use some magnet wire, and I have 100 picofarad capacitors. I think they're rated for 3000 volts. I have my two toroid cores, FT140-43, 43 mixed material, and I do have a Hammond 1594B case, and of course my capacitors, 30 kilovolts. I thought they were going to be 3 kilovolts, but hey, that's fine. I have 150 picofarads and 100 picofarads, and the schematic calls for 100 picofarads. One winding will be a 3 to 21 turns, so a 49-to-1 transformer. That's going to be for the lower bands, 80 and 40 meters, maybe 30 meters included. The other core I will wind for a 2 to 14 winding, which also is a 49-to-1 transformer, and that will be for upper bands, maybe 40 to 15 meters. Here's the design for the standard winding, which covers bands from 80 meters to 10 meters. Credit goes to Steve Ellington from the Unfed Half-Wave Antennas Facebook page, and K1TA, I think, for the drawing. 240-43 toroid core has an efficiency of about 90%. The 140-43 toroid has an efficiency of 70%, which is the one I chose, but I wanted a smaller box. This winding basically favors mid-range bands. The one I will try first will have 3 turns on the primary and 21 turns total. It will not cross over like the one you see here. Remember that every time the wire goes through the core, it counts for 1 turn. If you would like to know why it is a 49-to-1 transformer, well, we have 2 turns on the primary, 14 turns total. 14 divided by 2 equals 7. 7 squared equals 49. Why it's calculated like this? I don't know. Notice that this design will cover 80 to 10 meters with a 134-foot wire and 40 to 10 meters with a 67-foot wire. I'm going to get the parts of this failed 40-meter antenna here, especially the B and C connector. I have to unsolder everything. The air capacitor I might use for a magnetic loop antenna, maybe. I crushed it. What a dummy. I found one from another project. It's been outside, but it should work. 4 and 9 millimeters. I'm going to sacrifice a bit of wire here just to measure how much I need to make 3 turns on the primary. And I will scrape a little bit of the wire in the middle here. You'll see later why. I'll bend the wire here on a knife blade, thin one. There we go. You only should scrape about 1/2 inch just at the tip here. Now I'll grab it with the pliers and I will twist the two wires together, making sure that both wires actually turn, which is not that easy. This one is just my test wire to see how much I need. It's hard to film and twist at the same time. There we go. Now both wires are twisting. Now we'll go around the core 3 times. That's 1. Remember, this version is for the low band, so 3 turns on the primary. Well, that's a little too short here, okay. It has to reach the BNC connector. Actually, there wasn't enough wire. Wow. Okay, so the twisty part, well, maybe should be about this long for 3 turns. Now unwind it and measure it. It's about 17 centimeters. And there it is, 17 centimeters of twisty wire. Now I'm going to thread it through the core. And this is already 1 turn. And we need 3 turns. That's 2 turns now. Now we have our 3 turns, but it's a bit too long, so I'm going to have to untwist a little bit here. So this is going to the ground lug of the BNC connector, and this one is going to the center connector. So that would be 18 more turns around the core. Okay, so the 18 extra turns took 77 centimeters of wire, so now we have 21 turns total, 3 turns primary, and the rest goes up here to the antenna connection. For my second transformer, which will have 2 turns in the primary, I need about 10 centimeters of twisted wires. Actually, it was even less than 10 centimeters. Now I am up to 7 turns total. The next one, the 8th turn, will go through the center of the core and come out on the other side. It counts for a turn because it goes through the core. And this is what it looks like. Here we have the ground lug connection for the BNC connector, the center coax connector for the BNC. We have up to 7 turn, 8th turn goes through the core, 9, 10, 11, 12, 13, 14, and this wire here goes to the antenna. It took 53 centimeters on top of the 2 primary turns. And here are the 2 cores together. They're the exact same size. This is an optical illusion, making this one look smaller. This one is for the 80 to 15, maybe 10 meter bands, but more efficient in the middle. And this one is for the 80 meter band and maybe 40 and who knows, 160. Now I only have 1 case, so I think I'm going to use it for the 80 meter transformer. I just don't have the money to buy an extra case right now, so if you guys want to go to the Patreon link in the description and help me out, that would be awesome. Thank you. I'll start here by soldering the ground lug, including the one side of the capacitor. And I'm doing this left-handed for you guys. I cut the loop on the twisty wire so that one part of it would go through the ground lug. And I'm making a mess, of course. Good thing the Hammond case is fire resistant. I'm not associated with Hammond, by the way. They don't even know I exist, but I really like their stuff. Okay, soldering the center connector now. So the capacitor will be soldered on the other side. The capacitor is in parallel with the BNC connector. Let's solder the capacitor. Oh, it's a little bit too far behind here. And that, boys and girls, ought to do it for the input side. And let's not forget the antenna connection. Easy peasy. Later I will probably fill this with epoxy resin. I need to buy a few gallons for an upcoming project, not a radio project. You might know more about that later. So let's go out and have some fun with a 134-foot wire. I used the broken tip of a fishing pole to attach the wire to the mast. It will go between the tree on the right and the bushes on the left. So the antenna does form an inverted V. It looks like it's almost ready to to come out of the mast though at the top there, so I'm gonna have to release the wire a little bit. The transformer comes very close to the ground, and I don't like that much, but that's the kind of issue you encounter when you have antennas that long. Here's my installation today to test this antenna. The KX2, an SLA battery which weighs a ton, and my trusty Kent key. Now I'm not sure how long my wire is, because I know I've trimmed it a bit before, and it should be close to 132 feet, but I'm not quite sure. Let's tune it. 1.8 to 1, well, that's not bad. I mean, I'm sure I could correct that easily by trimming or adding some wire to it. So, wow, it works. Pretty happy about that. Let's try 7 meters. 1.5 to 1, 30 meters, 10 megahertz. 1.8 to 1, 20 meters, 14 megahertz. Oh, let's find an empty spot on the band. 1.5 to 1, 12 meters. 2.8, not that good. Oh, is that 17 meters? 15 meters, 21 megahertz. 1.6 to 1, very good. 12 meters. And 2.4, it's not made for those bands though. And 10 meters. 3.0, I think 10 meters needs what they call a compensation coil. But hey, I don't really care about 10 meters, so really happy with this antenna, this transformer. Awesome. Let's try it on 80 meters. I think it's too early in the day for 80 meters, it's 5:45 p.m. But hey, since this is a multi-band antenna with the 134 foot wire, we can try 40 meters. I just hate pileups, I just can't stand them. Too many people, I just change frequency. He's not going to be happy. Yeah, I'm not in the contest, buddy. That's asking if anybody's on frequency, QRL. No reply, wait a little bit and you can call. 30 meters. I'm really surprised it works on 30 meters. I mean, this SWR is good and it's receiving great. That's a good surprise. Guys, can't wait. It's all about the contact. There we go. Sucker. That kind of behavior is so freaking rude, you know. I just hate it. It's just unbelievable. I'm not doing a quick DX contact and he doesn't like it. I give him my first name, he doesn't like it. Crazy. It looks like I got a lot of reports on the reverse beacon network on 80 meters, 15 meters, 20 meters, 30 meters, and none on 40 meters, but I got a contact there, so very good. Of course, you know, CW mode, Morse code, it's a little too easy, so I'll have to try SSB too.
QRZ from Papa Alpha 2, London Ocean, stroke portable from Papa Alpha, Foxtrot 0044.
Foxtrot 4, Whiskey, Bravo, Yankee.
Foxtrot 4, Whiskey Bravo, Yankee, bonsoir, vous êtes 5 and 9, roger.
Bonsoir, thank you very much. And you are 57 here, 57, near the town of Lille, Lima, India, Lima, Lima, Echo, north of France. My name is Gilles, Golf India, Lima, QSL.
QSL, cher Gilles, dans l'île. Je m'appelle Gary, Golf Alpha Romeo Yankee, or hollandais Gert, Def Golf Echo Radio Tango. The name is Dutch, dear Gilles. Merci pour le 57 report, 52 pour vous. Fox 4, Whiskey Bravo Yankee, de Papa Alpha 2, Lima Oscar, stroke portable.
Merci beaucoup Gary, hein, merci beaucoup, bien reçu. J'opère portable ici, portable avec un KX2, KX2, 10 watts et une unfed antenna transformer 49 pour 1, 49 to 1. Over.
Roger, le 10 watts de KX2, c'est très formidable. Ici, en anglais, excusez-moi, I work with the KX3 antenna and a KX3 transceiver, and the antenna is an OptiBeam for 40-meter rotary dipole on a tower about 20 meters high right now, dear Gilles, and the output is about 400 watts right now, 400 watts, and you're on the side of the rotary dipole. Actually, I'm beaming more in the direction of the United States right now. Fox 4, Whiskey Bravo Yankee de Papa Alpha 2, Lima Oscar, stroke portable.
Merci Gary, hein. Bah, vous passez très bien, aucun problème ici. Hein. Merci beaucoup pour le report, hein, et puis bonne chance avec les États-Unis et une très très bonne soirée. Fox 4, Whiskey, Bravo, Yankee, à vous.
Merci bien, cher Gilles. Bon week-end et au revoir 67 Papa Alpha 2, Lima Oscar, stroke portable. Bye bye.
Have a good night, 73, goodbye.
Thank you. This is Papa Alpha 2, Lima Oscar, stroke portable from Papa Alpha, Fox 0044.
Well guys, this is a great success and I'm really happy about this transformer, 49 to 1, I'll tell you. It works multi-band with certain lengths of wire, 134 feet or I think 67 feet of wire. I will have to trim mine a bit because the tuning frequency, well, the resonant frequency is a little bit too low. So that's just a matter of cutting off a few inches at a time. And don't be too quick at cutting wire because I've done that many times. A big thank you to Steve Ellington for publishing this information about building the 49 to 1 transformer, because I'll tell you, this might have just become my favorite unfed antenna. And it works really well. It's multi-band with certain lengths of wire, again 134 feet or 67 I believe. I'll tell you, I even have an idea, because I really like this transformer, it works really well. What if I built a bunch of them? Would you guys be interested? Let me know. This concludes part 1. I'm really happy about the results, and part 2 will be about the winding for the middle bands with the crossover. So stay tuned. Have a good one.